Today we're going to look at determining which zeros are significant, because zeros can be written both as a placeholder and as an indicator of precision of the measurement. It's important to figure out which is which and how to distinguish between them. So typically what I would do is I'd start with something that looks like this. Okay, let's get this working here. Sorry about that. So then I would start with something that looks like this. And these are all non-zeros, of course. We would say there are 3 significant digits. And pretty much all, yeah, of course, most students would get that. The next example, and I typically put the numbers and put examples on the board and try to use these as teaching tools instead of using a whole lot of jargon. I put the numbers up and then we look at reasons why certain zeros are considered significant and certain ones are not. And that's typically the way I would go about doing this. So next I would put something like this up on the board. 4.021, 40.2, oops, that's a decimal 21. And let's go with 402.1. In each of these examples, the 0 is in between non-zeros. These zeros are in between non-zeros, so we would say that they are significant, and in all of those examples we would say there are 4 significant digits. Okay, next, zeros after or to the right of the decimal point, after to the right of the number, they are considered significant. So here's what I'm talking about here. Let's go 42.100, and let's go 421.00. So these zeros are to the right of the decimal and to the right of a number. Okay, and we would say that they are significant. Okay, they represent a certain the precision of a number, but they also represent that in this particular case, whatever took this measurement, it wasn't decimal 099 or decimal 101. It's precisely decimal 100. So these zeros and these zeros, they are significant, and we would say there are 5 significant figures in those 2 examples. Next, I'd show them something like this. This is an example of something merely holding a place, decimal 163. So that 0 there, it's kind of in the ones place. 3 significant digits here. Okay, most students will figure that one out pretty quick. Next, we have this one here. This one can be kind of tricky. Zeros after or to the right of the decimal point and before or to the left of the number, they are not significant. So here's what I mean by that. 0.00. Let's go 374. Okay, now let's have a look at this. Zeros after or to the right of the decimal, but to the left of a number, they're not considered significant. So these are simply holding a place, just the same as this is here. They're important. They're certainly important in terms of representing how small this number is, but they wouldn't be considered significant in terms of our significant digits. So in this one, we would say there are 3. Okay, and what I do when I first show students this one, I would cover these, and I would cover this with my hand and say anything measured here, and then they'd say no, and I'd have a cover here, hand over these 2. Anything measured? No. Anything measured here? No. And the minute I show this 3, then students would recognize that anything beyond this point here is considered significant and measurable. And that's the way I do it. So to elaborate on that, we would look at this and say, okay, 0, 0, 3, 7, 4, 0. In this example, we would say there are 4 significant digits. Okay, you know, nothing measured, nothing measured, nothing has been measured yet, the instrument hasn't picked anything up yet. Boom, as soon as you get here, anything after that is the machine or the instrument is picking it up, and we would say that anything after that, zeros included, would be considered significant. Now let's see if we had. There's a couple things when you're looking at some. This isn't a really big number, but let's say if I was to do something like this, 435,000. Now, if if you were given this particular number, 435,000, and you were asked for significant digits, we would say 3. And the reason for that is we're assuming that that's a rounded figure. We're not sure. This is not, we're going to assume that this is not exactly 435,000. It's a rounded figure. If we were going to look at something that is exactly 435,000, then we can express it a couple of ways. You never or rarely see it expressed like this, more so in science class, but if there's a decimal there, then that's telling us that this is an exact measured number, and it is precisely 435,000, and in that example we would say there are 6. Typically though, when you see something like this, we express numbers like this in scientific notation. So if I was going to take 435,000 and express it in scientific notation, I would write it like this here, 4.35 times 10 to the, and we would go, here's where my decimal is, 1, 2, 3, 4, 5. So 4.35 times 10 to the 5th power, 3 significant digits. If we were going to show all of these as being significant, expressed in scientific notation, expressed in scientific notation, then it would look like this, 4.35, and you'd have to express those zeros times 10 to the 5th. But in this particular instance, we would say there are 6 significant digits, and in this one, we would say there are 3. Okay, hope this helps, makes it a little clearer for you. Have a good day.